This is the 14th video in my series on three-phase power transformers. In this video, I'll be looking at delta-to-delta connected transformers. If you have been following these videos, you'll begin to comprehend that each of these videos are only a tiny percentage of my course entitled Electrical Three-Phase Power Transformer Fundamentals. You could access the 100% of this course and my other courses on my Stan Store at this web address. Before having a closer look at this type of transformer, we need to understand what third harmonics and tertiary windings are. Harmonic voltages and currents in an electrical power system are the result of non-linear electric loads. Harmonic frequencies in the power grid are a frequent cause of power quality problems. These in turn could result in an increased heating of the equipment and conductors, or the misfiring in variable speed drives and torque pulsation motors. When a non-linear load, such as a rectifier, is connected to the system, it draws a current that is not necessarily sinusoidal. The current waveform can become quite complex depending on the type of load and its intersection or interaction, that is, with other components in the system. All waveforms, no matter how complex, as long as they are repetitive, can be broken down into the sum of the fundamental sinusoidal wave plus multiples or harmonics of the fundamental frequency. And in order to analyze this, we have a system of doing that called Fourier analysis. However, just an understanding that complex waveforms, if repetitive, are made up of the fundamental frequency plus integral harmonics or multiples of the fundamental component harmonics. When analyzed, the third harmonic frequency of any sinusoidal wave is equal to 3 times the frequency of the fundamental frequency, and therefore, in a three-phase balanced system, we found that the third harmonic of all three phases are in phase with each other. This leads to the solution of a connection of a transformer in a delta configuration, and sometimes it is done with a third set of windings in a transformer called a tertiary winding that is connected in a delta configuration. Now let's look at a delta-delta configuration. In this configuration, one terminal of the primary terminals are connected to the system lines or buses. The other terminals are connected to the adjacent primary terminal. Similarly, one terminal of the secondary terminals are connected to the system lines or buses, and the other terminals are connected to the adjacent secondary terminal. That is to say, the H1 terminals are connected to individual phase conductors, and the high voltage H2 terminals are connected to the adjacent primary H1 terminal. Similarly, the X1 terminal of the secondaries are connected to the individual phase conductors, while the low voltage X2 terminals are connected to the adjacent secondary terminal X1. The transformer having its H1 terminal connected to the R phase, or the red phase, is referred to as the red phase transformer, and likewise a transformer with the H1 terminal connected to the white phase line or bus is, and is green in our diagram, of course, is referred to as the white phase transformer. And the transformer with its H1 terminal connected to the blue phase is referred to as the blue phase transformer. The vectors or phasors look like this, both primary and secondary. We'll put them both up at the same time because they're connected the same way or similar way. The red to white phasors, phase to phase, are shown here. The white to blue phasor is shown like this, and the blue to red phasor, both the primary and secondary, are shown like this. All of these phasors, of course, are rotating counterclockwise. No difficulty due to third harmonic circulating currents is encountered since the delta-connected windings provide a path for them. The third harmonic current vectors of each phase are in phase and will circulate in the delta as shown. The delta connection is used for transformation in a medium voltage ranges where a neutral point is not necessary for load purposes. Transformers with a delta-to-delta operation must have the entire winding and all the bushings insulated for the full line-to-line voltage of the circuit to which they are connected. Therefore, construction is more expensive. Star-to-star or delta-to-delta connections do not introduce any phase shift into the circuit from primary to secondary. Thus, all related primary voltages will be in phase with the related secondary voltages. Another solution to the problem of third harmonics is to provide a path for them using a set of tertiary windings connected in delta that allows for these circulating currents to flow. The provision of an extra set of windings increases the cost of the transformer considerably, which may be offset, of course, by using them to supply power to an extra load such as station service. This consists of a third winding on each transformer, or each leg of a three-phase transformer. They are connected to form a delta connection. The fundamental voltage vectors look like this, and thus the main transformation may be 230 kV to 110 kV with a circuit of 13.8 kV being fed from the tertiary winding for local use to tie in with synchronous condensers or to supply local power. The third harmonic currents, however, are rotating at 3 times the fundamental frequency, 60 cycles a second, and are in phase and will circulate in the delta as shown here. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. Some of those products include 𝐃𝐈𝐒𝐂𝐋𝐀𝐈𝐿 big and small standby generators. This is the best time to try out any of 𝐃𝐈𝐒𝐂𝐋𝐀𝐈𝐿's products because they are having a huge sale starting April 4th and lasting until April 21st. One of those amazing and versatile products is the 𝐃𝐈𝐒𝐂 Delta Pro Ultra, which can be modified to suit any homeowner's needs, operating virtually silent, and when paired with the 𝐃𝐈𝐒𝐂 Smart Home Panel 2 is extremely versatile. The 𝐃𝐈𝐒𝐂 Home Panel 2 ties any and all of your standby power equipment together and will control them efficiently. It will even control your connection to the utility grid to make sure you're only using the least expensive power, switching to your standby power during those expensive time of use rates. In order to view the full range of 𝐃𝐈𝐒𝐂 products, check into this website to browse the full extent of their products. There is no cost or commitment for viewing. To obtain more information on this subject, simply fill out the information requested when you go to this website. Before I end this video, I want to repeat the connection to obtain my free copy of the Ultimate Guide to Residential Standby Generators and receive access to the major April sales on many of the 𝐃𝐈𝐒𝐂 products. Also, here's the connections to obtain a free copy of my 50-page electrical power crib sheets. And finally, Here's the link to all of my electrical courses, which are located in my Stan store.